Lesson 45 homework was to use the Pico W, the OLED display, and the MPU 6050 to create a Tiltomatic, a 2D bubble level that also reports pitch and roll as text. Our Lesson 46 homework was to develop a strategy that would minimize the effects of vibration and other accelerations on the tilt measurement. Let's start by laying out the OLED display. The SSD 1306 display is 128 bits wide and 64 bits high. Many units, like mine, have a 128-bit by 15-bit section at the top that displays in yellow. We'll reserve that section for reporting pitch and roll as text. The remainder of the display will be our bubble area. We divide the bubble area into equal parts with a horizontal and vertical axis. The narrow axis of the breadboard is parallel to the IMU x-axis. The x-axis will represent roll. Roll readings will be displayed on the vertical axis of the bubble area. Similarly, the long axis of the breadboard is parallel to the IMU y-axis. The y-axis will represent pitch. Pitch readings will be displayed on the horizontal axis of the bubble area. Both axes will be scaled to keep the bubble entirely in the blue area of the OLED. The program will read roll data, which is XXL, and pitch data, YXL, from the IMU in a while true loop. The data will then be run through a low-pass filter to reduce some of the IMU's sensitivity to vibration and spurious accelerations. Follow the link in the description to watch Paul's 2019 explanation of low-pass filters. The filtered X and filtered Y values are used as the center of our bubble. Let's look at the code. We start with imports as usual. We import MPU 6050 because we're using the IMU. We import PIN and I2C. We import math because we're going to be doing some math functions. SSD 1306 underscore I2C because we're using the OLED. GC because we're doing garbage collection in the while true loop. And time because we're using sleep. Here we configure the OLED and the IMU. Here we define some key variables. Bubble radius for one, axis start and axis length variables, which control the length and starting position of the pitch and roll axes, min and max roll position and min and max pitch position variables, which ensure that the bubble doesn't leave the blue area of the OLED, and min XL and max XL, which limit the X and Y acceleration readings to values between -1 and +1. Here we define the confidence values for the low-pass filter. P1 is our confidence in previous data, and P2 is our confidence in new data. We also set the previous value variables used in the low-pass filter to 0 as a place to start. Before we enter the while true loop, we calculate the slope and y-intercept values, which will scale our pitch and roll readings to fit on the horizontal and vertical axes. Once we're in the while true loop, we perform some garbage collection and clear the OLED display. Then we input the instantaneous XXL value, XInst, from the IMU. We limit XInst to a value between -1 and +1. Then we calculate filtered XXL, XFilt. Remember, there's a link in the description to Paul's 2019 explanation of low-pass filters. Finally, we calculate the roll degrees and the X position of the bubble. Here we repeat the process for YXL data. We input the instantaneous YXL from the IMU. We limit the value to between -1 and +1. We calculate the filtered value, and then we calculate the pitch degrees and the Y position of the bubble. Finally, we display pitch and roll degrees in the upper text portion of the OLED and draw the bubble, which is centered at CXCY. If you need a refresher about how this works, there's a link in the description to Paul's Pico W Lesson 26, drawing a circle on the OLED 1306 display. Then we show all the changes we've made to the OLED, sleep briefly, and then repeat the loop. And here's how it works. Here we can see that the low-pass filter makes the program relatively insensitive to external vibrations. The bubble doesn't dance around too much on the OLED as the breadboard is being shaken. And here you can see the expected bubble level behavior. Well, that's it for this assignment. Any and all comments are welcome. Don't forget to like or dislike the video before you go. And feel free to subscribe. Don't forget the notification bell. We'll talk to you next time.